Welcome to another episode of Evolutionary Grounds. Around a century ago, in 1923, a truly immense cranial fossil was unearthed along the boundary between Mongolia and China. This fossil was just the upper portion of the skull, but it was clearly from a creature of incredible size. It bore a resemblance to a wolf skull but was significantly larger, over 3 times the length, while still sporting teeth that were equally sharp and perfectly designed for slicing through meat. This skull belonged to an animal that was eventually named Andrewsarchus, and upon closer examination, it became clear that it wasn't a member of the carnivore group like bears and dogs. It was indeed a mammal, but its closest relatives were animals like cows and horses. This was a hoofed meat-eater, an ungulate that used hooves for locomotion while pursuing prey and scavenging. The skull was found by Chen Pao, and initially described by Henry Osborn, who proposed it belonged to a group of extinct hoofed predators known as Masonicids, creatures that existed alongside Andrewsarchus approximately 45 million years ago during the Eocene period. Today, the dominant land predators across the globe are surprisingly uniform and lack significant diversity. With few exceptions, most large terrestrial hunters in various ecosystems are typically felines, and occasionally canines. However, around 30 million years ago and earlier, the situation was vastly different. Many regions of the world had their own unique forms of carnivores. South America had the boreanids, North America had creodonts, and even crocodiles briefly adapted to land-based lifestyles in European jungles. In Asia, and later spreading worldwide, were the Masonicids, predators unlike any today, not equipped with claws or talons, but rather possessing, or limited to, hooves. Despite having hooves, they likely shared many physical characteristics with wolves in terms of body and skull structure. Without claws, grasping prey must have been challenging, yet they appeared to thrive without them. They eventually became extinct, but it seems unlikely this was due to competition. Climate change is considered a more probable cause, although the exact reasons for their disappearance are still debated, especially given their success and widespread presence during the Eocene. Interestingly, the ancestors of whales are also thought to have been these peculiar carnivorous ungulates. For a time, it was believed that whale ancestors were Masonicids, a reasonable conclusion given their shared triangular teeth. However, recent discoveries and genetic evidence indicate that whales are actually artiodactyls, a group including animals like cows, pigs, deer, and camels. It's now suggested that Masonicids and artiodactyls were sister groups. This implies that whale ancestors were simply another lineage of hoofed carnivores that may have independently evolved meat-eating habits. This highlights the capabilities of these creatures, and that hooves weren't necessarily a major disadvantage. While Osborn initially classified Andrewsarchus as a Masonicid, this view was not universally accepted, even within the expedition itself, with some suggesting it was a large, pig-like omnivore. Andrewsarchus remains known only from this single skull discovered long ago, making inductive reasoning crucial for understanding its appearance. When encountering a new extinct species, particularly from fragmented remains, scientists often assume it shared traits with its closest relatives. This method, called phylogenetic bracketing, is vital for studying extinct animals. Imagine finding a skeleton of an extinct feline. If its remains suggest it belongs between 2 existing feline species, inferences about its appearance can be drawn from those living species. For example, if both living species have spots, it's reasonable to assume the extinct species also had spots, unless contradictory evidence emerges, like fossilized fur without spots. The assumption that Andrewsarchus was a Masonicid heavily influenced early artistic depictions, often showing it as wolf-like. But the most significant consequence of this Masonicid classification was the estimation of its massive size. Following the discovery, Osborn calculated Andrewsarchus's size based on proportions of a smaller Masonicid he considered a relative. This smaller creature was about 1.5 meters long with a 25 centimeter skull, giving it a body length 6 times its skull length. Applying these proportions to Andrewsarchus's nearly meter-long skull resulted in an animal approaching 5 meters in length. This was an enormous size, and Osborn acknowledged this, declaring Andrewsarchus the largest mammalian carnivore ever. However, the Masonicid classification of Andrewsarchus has been questioned since its inception, and a 2010 study largely refuted it. This research indicated Andrewsarchus belonged to Cetancodonta, placing it much closer to whales than Masonicids. Cetancodonta includes whales and their terrestrial ancestors, like Pakicetus, but also hippos. Skulls of many Cetancodonts do show similarities to the Andrewsarchus skull. So, Masonicids weren't closely related to whales, but Andrewsarchus was. The closest relatives to Andrewsarchus within this group are entelodonts, often called hell pigs, a diverse group prevalent for around 20 million years in the mid-Cenozoic. Entelodonts generally had skulls proportionally larger than Masonicids. For example, the entelodont Diodon was about 2.5 meters long with a 65 centimeter skull, meaning over a quarter of its body length was skull. Using these proportions for Andrewsarchus reduces its estimated body length to a more plausible 3.5 meters. Classifying Andrewsarchus as an entelodont relative suggests a smaller size than Osborn envisioned, though still one of the largest mammalian predators known. Knowing Andrewsarchus's likely relation to entelodonts also suggests a similar lifestyle. Entelodonts are thought to have been omnivorous, consuming whatever they found, likely primarily scavengers with occasional hunting. This omnivorous scavenging lifestyle makes sense for Andrewsarchus, as the largest land predators today, bears, are omnivores and sometimes hunt. This lifestyle would better explain how such a large animal could thrive in its ecosystem. Masonicids, Andrewsarchus, and their entelodont kin are now extinct, superseded by clawed carnivores. However, these creatures permanently demonstrate that when it comes to hunting, claws might be overrated. If you want to support me in this channel, consider becoming a Patreon. Thanks for watching and have a good day.